Alrighty, folks, here we are. We're going to be finding distances and midpoints given a couple points on a graph or just the coordinates of it. So find the distance between 2 points and find the midpoint on the line segment joining the 2 points. So distance, recall that formula, and I'm going to make a change on here. I think it makes it easier, but we're basically taking the difference in the x's. I don't care which one's the first one, which one's the second one, it doesn't matter. When you calculate slope, it does matter the order that you subtract. What you do on the top, you have to do on the bottom, order-wise. So I'm just going to think of this as the difference of x. And this right here is the difference of y. It makes things go a lot faster, and honestly, I think it makes it more accurate. Because sometimes when we just do too many calculations, we can make some mistakes. So I'll show you what I mean. So in parentheses here, I'm going to square whatever the difference is in the x's. So what's the difference between 4 and 6? It's 2. Now I don't care if you write 2 or negative 2. I'm going to write positive 2 because I like using positive numbers and it's less writing. But when you square positive 2 or when you square negative 2, you still get 4. So it doesn't matter the order that you subtract because squaring undoes that negative value. We'll change colors. Now in the second parentheses, we're going to square the difference of the y's. So picture a number line. What's the difference between negative 3 and positive 2? Well, it takes 3 steps to get from negative 3 to 0. That's 3 steps, and then it takes 2 more steps to go from 0 to 2. So the total difference is 5. When one's positive and one's negative and you want to find the distance, you basically just pretend that's a positive number and you add 3 and 2 because you have to travel between the negatives and the positives. So anyway, that's 5 squared. So then we get, now you need to simplify what's in the parentheses or what's underneath the square root first. So 2 squared is 4, 5 squared is 25. That makes 29. So final answer would be the square root of 29, bada bing, bada boom. Now let's do the midpoint. So we're going to add the x's and divide by 2 and add the y's and divide by 2. You're finding the middle or the average of the x's. So the average of the x's is 4 plus 6 divided by 2, and the average of the y's would be negative 3 plus 2 divided by 2. Clean up the tops first. So we get 10 over 2 for your x midpoint and negative of 1 over 2 for your y midpoint. That's the same as 5 comma negative 0.5. That's how we do it. I'm going to go a little faster now. So distance formula, taking the square root of, difference of the x's is 6. I need to square that. Plus the difference of the y's. Negative 5 up to positive 6 is 11. So I'll need to square that. Now simplify what's underneath the square root. You got 36 plus 121, which is 157. And that's a good answer. Or you can use your calculator too. Doesn't specify which one to do, so I'm going to leave it like that. Midpoint, add the x's. So negative 2 plus 4 over 2. And y's are negative 5 plus 6 over 2. So we get 2 over 2, comma 1 over 2. They should be in parentheses, by the way. Usually just at the end go back and give a pretty answer in with parentheses. So there we go. There is the midpoint. Number 3, distance. So the square root of 8 squared plus the square root of 6 squared. So you get 36 and 64. Seems like, ooh, I made a mistake. Naughty. Naughty. The difference here is 4. Right? The difference between 2 and 6 is 4. So that should be a 4 squared. So we get 16 and 36, which is 52. Huh. Super naughty, Mr. P. Alrighty, let's do the averages to find the midpoint. So we'll add the x's and divide by 2, and we'll add the y's and divide by 2. So we get 8 over 2, which is 4, and we get negative 4 over 2, which is negative 2. There we are. The vertices of a triangle are given. Classify them as scalene, which means they have no congruent sides. Isosceles means they have two congruent sides, or equilateral means all three sides of the triangle are the same length. I like to label the points A, B, and C. So we need to find the lengths from A to B, from B to C, and A to C. So I'm going to focus on A to B first. So I'm going to highlight those two just so they pop a little bit better so Mr. P makes less mistakes. So let's do the square root of. Let's find the distance between the x's. That'd be 5. So 5 squared plus distance between the y's is 1. We'll square that so we get the square root of 26. And you can leave it just like that, folks. B to C. Now let me move my highlighting over. Get rid of this. So distance between -1 and 3 is 4. We need to square that, plus the distance between -1 and 5 is 6. We need to square that, so we get the square root of 36 plus 16 is 52. So those two sides are not the same length. And then A to C. So 4 to 3 is 1. Plus distance from 0 to 5 is 5. So here you get the square root of 26. So that means AB, the length of AB is the same or equal to the length of AC. So there's two sides that are equal, so that makes the triangle isosceles. Boom. Number 5. All right. Let's make a little more room. Number 5, let's do the same thing. So I'd like to label the lengths A, B, and C. And now let's start calculating. So A to B, let's see. So the distance from 8 to 1 is 7, so we'll square that. Distance from 5 to -2 is also 7, so we'll square that. So we get the square root of 98 for the distance from A to B. Let's go B to C. So the distance from 1 to -3 is 4. We'll square that. Distance from -2 to 2 is also 4, so we'll square that. So we get the square root of 32. And last but not least, A to C. A to C, so let's see, that's 11. So we'll square 11. And then 5 to 2 is 3. So we'll square that. So we get 121 plus 9, which is 130. So none of these lengths are equal, so it's scalene. Last but not least, use the distance formula to solve for x. So remember, our distance formula looks like this. Now we'll actually have to use that technical formula. So x1 minus x2 squared plus y1 minus y2. I think your distance formula might have y2 minus y1 and x2 minus x1. What matters with calculating slope, and now in this case, is that we have, if you have a 1 and then a 2 for the x's, you have a 1 and then a 2 for the y's. Your subscripts have to be in the same order for the x's and the y's. So now we substitute what we know. We know that the distance is the square root of 53, so I'm going to put the square root of 53 right here. And then we have -3 minus 10 squared plus 2 minus x. You know what? Shoot, I'm going to switch this. Because I want this x to be positive, so I want x minus 2 in this other parentheses. It's confusing because they call x represents the y value actually. But so I want x minus 2 over there for my y's. And then that means I want -10 minus -3. And I think I left off a negative sign too when I wrote that first as well. Be really careful with that. So it's -10 minus, it's always subtracting for distance of the x's, and then it's -3. All right, so here we go. You know, the first step we can really do is everything on the left and everything on the right is getting square rooted. So let's square the left and the right side. What that does is then undoes the square root sign. So we get 53 equals, well, chop chop, that's really a negative 7 squared plus x minus 2 squared. Negative 7 squared is 49. So I'm going to subtract off the 49. Minus 49 minus 49. Needs more space. So we get 4 equals x minus 2 squared. Now we want to undo squaring, so we square roots and square roots. So we get plus or minus 2 over here, right? Because negative 2 times negative 2 is also 4. Equals x minus 2. Don't know why I changed colors, but I was just feeling it. Should be able to get more space here, right? Hello? Hello? I don't know what to do. I know what to do. Let's take all this stuff and shove it up there. And so then from here we just add 2. Plus 2, plus 2. So we get a positive 2. That's the plus 2 that I just wrote down. Plus or minus, from undoing minus 2. Plus or minus 2, because the red 2 is positive and negative, equals x. So now that means x equals 2 plus 2 and x equals 2 minus 2. This equals 4, this equals 0. What makes the most sense? Well, actually, they're both correct if you plot it. So that's not a coordinate pair, that's a squiggly fancy pants bracket. Our answers are 4 and 0. Plug it in and check it. You'll actually get the distance of a square root of 53 using either answer. There's 2 locations that make that distance happen from the coordinate pair negative 3, negative 10. Let's try it again. So plug in our distance, square root of, and then we plug in our x's and our y's. I'm going to actually go back to the y's first because I want the x to be positive. So I want x minus 7. So I'm subtracting in that order. So then I want 3 minus 5 over here. Well, honestly, it doesn't matter actually here, folks, either, because squaring a negative number makes it positive. Ooh. Now from here, there's a few first steps you could do, but like you could simplify in there first. Let's square both sides. Now careful over here. You need to sprinkle that power of 2 to the 2 and to the square root of 17. So you get 4 times 17, which we'll simplify in a little bit. Here you get, well, that's negative 2. Negative 2 squared is 4. So you get 4 plus x minus 7 squared. And here we get 68 equals 4 plus x minus 7 squared in parentheses. So we subtract 4. Subtract 4, we get 64 equals x minus 7 quantity squared. So we'll need to square root each side. Now when we square root the left side, we get, I better show it, square root, we get plus or minus 8 equals x minus 7. So all we have to do now to get x by itself, to figure out the location of that missing coordinate, is to add 7 to each side. So we add 7, we get x equals whatever 7 plus 8 and minus 8 is. So 7 plus 8 is 15, 7 minus 8 is negative 1. There are our 2 answers. That's not good. I might have goofed that one up. I don't know. My answer disagrees with the answer over there. Back up to the top. I'm going to just check it real quick, and then I'll at least know if I screwed up or not. Oh, I really